Hello, welcome to Tennessee's At-Home Learning Series for Math. Today's lessons for all our sixth graders out there. All children are welcome to tune in. This lesson is the 7th in our series. My name is Reggie Caruth, and I'm assistant principal here in Tennessee Schools. I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons since we will be talking about things previously learned today. So today we'll be learning about dividing when the divisor is a fraction in mathematics. Before we get started, to participate fully in today's lesson, you'll need the following: paper and pencil and a surface to write on. Y'all ready? Let's get started. All right, students, let's jump in. Which would you rather? Students, look at the two given situations and determine which would you rather have and why. So the first situation, 3/4 of 1/3 of an apple or 1/3 of 9/10 of an apple. Again, I want you to figure out which one would you rather have and why. All right, so let's share some possible solutions. Your answers may even depend on even if you like apples. I love apples. So you might have said A because it is the lesser amount of 1/4, or you might have said B because it is the greater amount of 3/10. They are both great observations. These build on your knowledge that you have of taking fractions of a fraction from 5th grade when you multiply fractions. So keep in mind that a fraction is a number that names equal parts of a whole. To review, let's draw a fraction circle. So we're going to draw a fraction circle. And from that fraction circle, I'm going to divide this up into 8 parts. 2, 4, 6, and 8. Now, I want to shade 5 of those parts. 1, 2, 3, 4, 5. So this is a fraction circle. All right, so let's review how we divide a whole number by a unit fraction. We may need a model to fully understand what the problem is asking. So here's our problem. Mr. Putnam wants to cut a 3-foot rope into 1/4 foot sections. How can we determine how many sections he will get? Again, Mr. Putnam wants to cut a 3-foot rope into 1/4 foot sections. How can we determine how many sections he will get? I'm gonna give you a second and I want you to solve it. All right, so what we're going to do is we're going to create a visual to fully understand what this problem is asking. A model is a visual representation of the numbers represented in a problem. Visual fraction models that we have used before include area models, fraction circles, number lines, fraction bars, and many more. So let's start with the number line. I want to use a number line that can help us out. You can draw a number line that represents 3 feet of rope. There are 3 1-foot sections. So let's draw my number line. So here's my number line to help represent this problem. There are 3 1-foot sections. So I have 1 foot section, another foot section, and another foot section. What do you think we should do? Right. You should mark fourths on the number line to represent a fourth of a foot. So let's start marking. All right, so I know that this piece right here represents my fourth. So you can see that there are 12 1/4 foot in each section of 3 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can write this problem as 3, 1/4 gives me 12, because I know when I divide this 3 feet into my fourths, I have 12 fourths in here. So here's my answer. So when you divide 3 by 1/4, you are dividing 3 into parts smaller than 1. So there may be more than 3 of those parts. Let's dig a little deeper into situations where we are given a fraction or something, such as a half of an apple, and are asked to find a fractional part, such as a fourth of that half of an apple, to share with someone. So we're going to solve this problem together. You can use words, numbers, drawings, or models to solve. So Mia has a ribbon that she wants to cut into smaller parts. Mia cuts her 6-yard length of ribbon into 3/4 yard pieces. How many pieces of ribbon does Mia have now? Again, let me read it one more time. Mia has a ribbon that she wants to cut into smaller parts. Mia cuts her 6-yard length of ribbon into 3/4 yard pieces. How many pieces of ribbon does Mia have now? I want you to try to solve this. Remember, you can use words, numbers, drawings, or models to solve. Make sure you're looking at the information that you need to know to solve this. Great work. Let me show you how I solved it so you can compare. So Mia cuts a 6-yard length of ribbon into 3/4 yard pieces. To figure out how many pieces Mia cut, I need to consider how many 3/4 are in 6. What do you think? How many 3/4 are in 6? Well, let's use a number line to find this out. So I'm going to draw a number line. And why did I go up to 6? Correct, because we know Mia cuts her 6-yard length ribbon. So now I'm going to divide this up into fourths. Anybody know why I did fourths? Correct, because I know I'm working with 3/4 yard pieces. So now I can circle my 3/4 section to represent my 3/4 yard pieces. So let me first start and circle my first one. Two. You circling? So what's next? What's next? Oh, make sure that this is going all the way to where it should. So now, we're gonna keep going. All right, so this shows me how many is in 3/4 are in 6. So how many 3/4 yard pieces are in 6 yards? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Correct. That is 8 pieces. Good job. Good job. So let's try another one together. So I just wrote this one up for you. It says Kate has 2/3 yards of fabric to make small flags. Each flag requires 1/6 yard of fabric. How many flags can Kate make? First, what do we need to know? Correct. We need to know how many 1/6 are in 2/3. So since we learned about double number lines in school this year, let's try one. Remember, a double number line is often used when two different units or measures of equivalence are being compared. They show each of the quantities on its own number line with corresponding values lined up. Here's an example of a double number line with fractions. So I'm going to draw my double number line. So my first number line, to make sure my corresponding values line up, I'm going to break my first number line up into thirds. So if this is 1/3, what would this be? 2/3, correct. So now I'm going to break this one up into 6. So looking at this, I already can see from here that 1/3 is equivalent to 2/6. So now let me find what's equivalent to 2/3. So if this is 1/3, this has to be 2/3 since I know it's broken up into a third. So this is going to be my equivalent fraction on this line. So if this is 2/6, what does this have to be on my double number line? Especially since I know my bottom number line is divided up into 6. Correct. This represents 4/6. So now I can figure out how many 6 are in 2/3. So I'm going to start circling. Here's 1/6, another 6, another 6, and another 6. So how many 6 are in 2/3? Correct, 4. So let's bring it all together. So I know that I have 2/3 yards, and I'm going to divide that by 1/6, and that equals 4. Good job. Let's do another one. Let me write another one down real fast. All right, so here's my next problem. It says Eli ran 3/4 of a mile. Every eighth of a mile, he jumped over a hurdle. There was a final hurdle at 3/4 mile marker. How many hurdles did Eli jump over? Let me read it one more time. Eli ran 3/4 of a mile. Every eighth of a mile, he jumped over a hurdle. There was a final hurdle at the 3/4 mile mark. How many hurdles did Eli jump over? So where do we begin? Correct. Let's look at what the problem is asking us to do. What is the total distance that Eli ran? Correct. He ran, the total distance should be 3/4 mile because it says it's at the final marker. What intervals do we want to divide the 3/4 of a mile into? Correct. 1/8. So let's use another double number line to represent this situation. So let me draw my double number line. So let's divide our top number line into fourths. Why fourths? Great, because we know that his total distance was 3/4 of a mile. So this would be 3/4. So this would be represent a fourth. This will represent 2/4. This will represent 3/4. So I'm gonna also do the corresponding marks on my bottom number line. So now, what do I want to break my bottom number line into? Yes, I want to divide it into eighths. So I know that this is an eighth. This is what, 2/8 or an eighth, 3/8 or an eighth, 4/8, etc., etc., etc. So my bottom number line is divided into eighths. So why do you think the visual model helps us figure out how many hurdles Eli jumped over? I agree. We can count how many 1/8 are in 3/4. So let's count. How many 1/8 are in 3/4? 8, 6, 8. So let me see. Let's start counting. 1, 2, 3, 4, 5, 6. Correct. So there are 6 in. So now let's bring it all together. So what does this mean? Right. So there's, I'm going to have 3/4, and I'm dividing it by 1/8. That equals 6. Because there are 6 1/8 and 3/4. In these problems, we were trying to use what we already knew about fractions to solve the problems. We used number lines to model the division. We had to understand that the given information and how it could be used to determine our division problem. I'm going to try a few more out with you, so stick with me. Let's do them together. Let's do 2 together so we can make sure you understand and we can see different ways to represent a problem. So here's our next problem. All right, so now that you've looked at this problem and used your model, where did you begin? Remember that your model doesn't always have to be perfect. It is a way to help you think and see what the problem is representing. So again, where did you begin? Okay, from what I'm hearing, you all are heading in the right direction. When you begin with 3 cups of glue and know that you're dividing it by 2/3 cups of glue for each batch, there are multiple ways to model this. Here are 2 possible ways you can do it. So here's one. We can do so now I have my model broken up. So I know that each of these represents 1 cup. So that's 1 cup, that's 1 cup, or together 2 cups, and that's 1 cup, or together 3 cups. So now I need to divide each cup up into 2/3. So I know that this represents a third, this represents a third, represents a third, represents a third, third, a third, a third, and a third. So now I can go ahead and mark my 2/3. So here's 2/3 in 1 cup. Here's another 2/3. Here's another 2/3. Another 2/3. And we're going to talk about this last piece in a second. So I know that this is 1, 2, 3, 4 batches. But what about this last batch? So 1, 2, 3, 4. But what about this last batch? I know that 2 of the 1/3 make 1 batch. But this is half of the 1/3. So how many batches does this make? Correct, 1/2. So I can make a total of 4.5 batches. I can do the same thing with the number line. So I'm going to show you the same way with the number line, and then we're going to bring it all together. So same information. Just going to use a number line. I'm going to break this up into thirds. So now, I'm going to show my 2/3. 1, 2, 3, 4. And the same thing here. I have that little extra left over that's going to represent my half. So 4.5. So no matter what model you use, you still get the same thing. So what does this show us, or what does this tell us? Looking at this model, my number line, or this, this lets me know that when I have 3 cups of glue, and I'll divide that into 2/3 cups, I can make 4.5 batches. That's fun times, y'all. All right, here's one for you to work all the way through. Don't forget to tie it all together at the end to ensure that you're answering the given question. Y'all ready? So here's the next one. So the next problem says, Sophia has pitchers that each hold 1 2/5 liter. She has 4 1/5 liter of iced tea. Which division expression can you use to find the number of pitchers Sophia can fill with iced tea? 1 2/5 divided by 4 1/5, or 4 1/5 divided by 1 2/5. As you're working, I'm going to read the problem one more time. Sophia has pitchers that each hold 1 2/5 liter. She has 4 1/5 liter of iced tea. Which division expression can you use to find the number of pitchers Sophia can fill with iced tea? So it's either 1 2/5 divided by 4 1/5, or 4 1/5 divided by 1 2/5. So if you said 4 1/5 divided by 1 2/5, you are correct. So now we need to figure out how many pitchers can Sophia fill. So with the number line provided below, I'm going to start filling in information that I know. So I know this is going to represent, I'm going to fill in my number line. So I know this is going to represent 1, 2, 3, 4, and 5. So now I'm going to divide up here. What do I want each mark to be divided up by? 1/5. So Ooh, messed up there. It's all right. All right, so now I can go ahead and start dividing up. And since this part is messed up, I'm just gonna black that out. All right, so I know that I'm doing 1 2/5. So my first one is gonna represent 1 2/5. So the next one will come to here. And that's 1 2/5. My next one will come to here. And that's 1 2/5. So why do I want to stop here? What does this represent? Correct. 4 1/5, which is what I'm getting to. So now I need to figure out how many 1 2/5 are there, are in 4 1/5. So this is 1, 2, 3. So I know that there are 3. So that lets me know that Sophia can fill 3 pitchers of sweet tea. So bringing it back all together, I'll take that. I know that 4 1/5 divided by 1 2/5 is going to give me 3. Great work. Today we reviewed dividing fractions by fractions. I hope you're seeing some connections to models in multiplication when dividing. You sure did do a great job. After the video, you'll have some problems to practice on your own. You can find these practice problems on the Tennessee Department of Education's website at www.tn.gov/education. Good luck and do your best. I have enjoyed dividing fractions by fractions with you all today. Thank you for inviting me into your home. I look forward to seeing you in the next lesson on Tennessee's At Home Learning Series. Goodbye.